I can record with a little bit more reliability. I want you to tell me, I want to add a new model here. How do I add a new model? Good. That's right. So File, New Model. Good. New Model. And we're going to call this weight and diabetes dynamics. Okay? And I'll call it SAX 2015. Weight and diabetes dynamics. Okay? Gives you some sense what lies before us. And ladies and gentlemen, I'll be exploring things that they've not covered before, certainly in this year of Fair Continent. We're going to see a couple. We're going to build on some of the understanding from our work thus far, but we're going to focus our attention on some of the features that we haven't looked at. I mean, we just had a model which exhibited heterogeneity, which is one of the big, it's not to be minimized, it's one of the big draws for use of agent-based modeling. I spoke with you yesterday about how heterogeneity sometimes has a disproportionate impact. A small fraction of the population, distinguished by certain characteristics, has a disproportionate impact on outcomes. So these are sometimes individuals with large numbers of connections, individuals who serve as kind of a hub for detecting new trends, new norms, or new pathogens, and then disseminate them in a very pronounced way. Sometimes it can be individuals who have certain behavioral characteristics or certain visibility. And if we're going to focus on interventions that are cost-effective, sometimes it behooves us to target these particular subgroups. So capturing heterogeneity within models is often, with these dynamic models, is often a real, very important step of the process. And it turns out that aggregate models, system dynamics models, have real scalability issues when applied at an aggregate level for capturing heterogeneity. You capture it by stratifying the model. So you have a separate version of the model for men and for women, essentially. And then if you start at different income quintiles, you multiply it again by a factor of 5 in size. And then if you have education levels, multiply it again by the number of divisions there. And you're keeping track of all possible combinations of age and sex and income and education, and it starts to really blow up. And so agent-based models make it very convenient to add in heterogeneity. So we just had that model with sex and income. Suppose we want to have education as a characteristic there, and we want to distinguish, say 3 education levels, for example, primary, secondary, and postgraduate school level attainment. How could we do that? Sorry? Add a new parameter. Yeah, we add a new parameter to a person. It's a very localized change. It doesn't require changing everything across the model like it does in an aggregate model. Rather, it's a very localized change. You add in a parameter, and there'll be some specifics to that parameter. Maybe we'd have an option list to describe the 3 options. And that parameter, like sex, would refer to the option list. Sex referred to capital SEX, that option list we had to include male and female. You could do the same thing with education, but it's a very neat sort of component. So what we've seen is actually important, and we've seen how that can be hitched up to visual representation. And that also, I've argued, is important. But ladies and gentlemen, in this session, we're going to add the dynamic into dynamic modeling. Because thus far, these models we've been looking at, well, they've captured heterogeneity. They've not captured the dynamics. They've not captured change over time. They've not captured behavior. And we want to capture behavior. And this lies before us as the purpose of this next session. So we turn our attention to none other than the enterprise of adding behavior to this model. Great. So, are you ready to begin? Good. Steeled by those muffins? Being quaffed caffeine? You're ready to move forward. Great. let's move forward. I want to add a theory of personhood here. Persons here will not be static, but they'll be dynamic. But what do I have to do to add a population of persons? Count for me the steps. I want to add a population of persons. What do I need to do? I need to a new agent. So there's this agent that describes, that operationalizes the theory of personhood, how personhood could work. Sometimes this is a theory about how the world works. Sometimes sometimes we want the model instead. We're not trying to describe how the world works specifically. We want to say, if the world worked this way, what would the logical implications be? Maybe we'd see, with these very simple assumptions, just these two assumptions interacting, we get this pattern of behavior that's very similar to what we see in the world. That's learning that's gone on there. It's opened up our understanding of the logical implications of our theory. And maybe we have a much richer theory about how the world works, but that's a piece of it, and now we don't have to worry about that pattern being explained, needing to be explained by other recourse to other things. We instead realize it could just result from these simple interactions. It's not saying it definitely does, but it's saying it's plausible, perhaps. So we're going to build this theory of personhood with, again, an impoverished theory. So how do I add a person in here? Okay, so we could right-click on this and do new and do agent type. And we're going to call it person with a capital P. Why capital? Why capital? Yeah, it describes sort of the concept of person. It's not one particular person. If there were one particular person, and there will be cases of this, we'll want a lowercase p person to refer to that particular person. Dylan in the corner there. With lowercase p. Yeah. Never mind the fact he spells it with a capital D. But, okay. So his parents didn't understand the conventions of Java. Okay. So we have capital P person in here. Okay. Great. We want to lend this person an appearance. Let us give them a appearance in the form of a shape of a person. So how would we do that? Where would we look to add in some appearance to the person? Where would we go? To the palette with a capital P. Okay, and then we would go, and you might look at presentation, but you'll find that it's bereft of these sort of characterizations. Instead, you need to go down here to where it says pictures, and the world opens before us. And I know what you folks are thinking, don't I? The fighter jets. Leave those to the Prime Minister. Let's instead add a person here. So we're going to add a person, the person shape in there. And some of you may wish to partake of patients or nurses or doctors, but let's not have a lot of lorries going around and ships and so on. Okay. We had one model where doctors were depicted by fighter jets, by some imaginative person. You could just imagine the orthopods circulating and their afterburners on. Okay, so we just added in the person here. That's good, and there's a little bit of focus issue here, so that's a little bit better. Yeah. Okay. Come on. Oh, come on. Okay. Is that better? Little. Yeah. Okay. A little bit better, I think. Okay. So we just dragged this person in, this image into a person. It's easier if you drag this image in before creating the population, just as an aside. There's ways to deal with it after creating the population if you drag in a appearance, but it's easier, trust me, if you do it here. Okay. So you dragged in this picture. Okay, that's great. Now we'll go elaborate things here, but how do we add a population of these people? How do we add a population of them? Rehearse that for me. This is like your daily squats before you run. So what do we have to do? Yeah, go to main, because that population needs in main. Good. And then what do we add to main? Okay, drag the person into main. Excellent. So why is it that it's showing me this? Because I drag it into person. Got to be very careful to where you drag it in, particularly when you're jet lagged. So drag it into main. Great. And we'll say population. But is that really a population yet? I've said population, but is it really a population at this point? What do we still need to do to turn it into a population? Yes, we need to click this population of agents. Okay. Now, I told you we're going to build on what we just saw earlier. And this is something I didn't much emphasize in Adelaide, but it's an important point, and I'm going to emphasize it now, and hopefully I'll return to it. Ladies and gentlemen, we could run this model. Let's go run this. What do you think will happen when we run this? What will we see? Okay. So the 100, will they be circles? Okay, but will we see them spread out like a phalanx before us? No, where are they? They're all atop of each other up there. They're all standing astride each other, and you can't tell the difference. How do we know? Do we have a population? And what's its size? 100, indeed. We're going to come back and revisit it. Okay, we're going to come back and make it larger. But how would we spread them out? How would we make those people so at least they're not gratuitously overlapped? Suppose we want to spread them nice and evenly between that space. Where would we go? Whither would we go? We go to main, population, and initial location. So we're going to say we're going to put them at this initial point, and I want to draw their X and Y locations right now. I'm going to draw it from a uniform distribution. How would I do that? Between 0 and 500. How would I do that? Uniform. That's right. Uniform, 0 to 500, and same thing for Y. Is it not? True or not? True, indeed. The eyes have it. Okay, and then you can build up here. No? And build or build often. What will we see now if we run this model? Try to do this. Try to run these models frequently and see what your work hath wrought. Because sometimes you discover earlier mistakes you've made, and sometimes it leads to insight. So here we have these people spread out before us. Hardly a phalanx, but impressive. Okay, so we've spread these people out. Do you see this on your screen? Because if not, Dylan awaits. Okay, who would like Dylan services? Okay, deployment to Sector 2. Okay, great. Great. There's a dual conflagration to Sector 2. Okay. Good. Who else needs help? Okay. You people following along? Okay. So the next thing we're going to do is we're going to make this population, instead of being fixed at 100, we're going to make the population be variable. We want to be able to set a population. Let me ask this, ladies and gentlemen. When we had each person have a sex or an income in that last model, where did we specify the characteristics for those people in the model? Where were their distributions associated with their income specified? Where did we go to do that? Where did that information live? Okay, did it? And it lived in Maine, and particularly in what thing in Maine? In the parameters for the population, right? Okay, so if any of you are familiar with the magic flute, you may have thought I was imitating Papagena, but we'll leave that for another time. Great. So it's specified in the population. In general, ladies and gentlemen, and this is a unifying point with any logic. If we have some object as an agent, okay, an agent, or we have this sort of this object of a person, the characteristics of that person, the parameters, they're set associated with the thing that's responsible for creating that person, which is, in this case, the population, brings that person into existence. Soon enough, we'll be seeing open populations where people are born and disappear, and there'll be some need to specify it at the point of the birth, too. But basically, it's where that person's created, and the population takes care of creating people, okay? So we specify those characteristics there. Okay, now the parameter there in that person provides a conduit. It both specifies the assumption and it communicates it to that person. Remember that we had person and they had an income parameter, and that parameter encoded some assumption about their income, and it communicated to them from the population. The population specified when in the population it specified some rules for characterizing it, and it was communicated to it. Now suppose we're in Maine and we want to be able to specify a different population, an assumption about the population size. That's not an assumption about any one agent. It's an assumption about the population size. Where would we go? What way could we both capture that assumption and communicate it to Maine? What any logic construct from the palette would we use to communicate and encode an assumption? I just told it to you. For a person, what thing do we use to communicate and sort of specify that assumption, to encode that assumption about their income? What did we use? We added a parameter. So we can add a parameter to Maine. And that parameter is going to be about the population size. Does that make sense? It's going to be a thing not specific to any one agent. It's not beholden to Dylan or even to Jeff. But instead, it's a characteristic of the population as a whole. So it's characteristic of the whole scenario. So we're going to be specifying a parameter in Maine called population size. Okay. So let's open up Maine. Let's go down Maine. You can double click on it over here if it's not already open. Let's go to the palette. And where do we find a parameter in the palette? Or from whence do we find it? Excuse me. It's in agent, kind of confusingly, but let's drag in parameter here. And let's call it population size, lowercase population, and then capital S-I-Z-E. Do you call it Z here? Is it Z? Z, yeah, okay. We're at home. In the States, I always have to map it. Z, okay. Yeah, yeah. I think Calgary tends to pronounce it. People from Calgary, I've noticed, tend to pronounce it with Z. I guess so. All those flights to Tucson, or to Houston rather, end up having some effect. Yeah. Yeah.
The provinces in Alberta is oil rich, lots of bad land, lots of cattle and everything like that. So we like to joke that sometimes political information is anyway.
In any case, population with a lowercase p and then capital S I-Z-E. Okay, there's no space between those. Okay, population size. Yeah.
And if anybody's wondering why I'm using a capital S in the middle of that, it's just programmer notation. So because you can't put a space in that word,
yeah.
Some languages basically just said, okay, every time you start a new word, you just put a capital letter there. And after a while, it makes it easy to read and parse. So once you get used to it, it's like, oh, population size. Fine.
Yeah.
It'll take a little bit of getting used to.
It lets you sort of parse what the separate words are. Yeah. Fair enough. Thank you, Dylan. Okay. And so, ladies and gentlemen, so riddle me this. So this parameter will encode and communicate the value of parameter size of the population size. How are we going to actually make that the population size? How are we going to actually operationalize it? We could have called it Fido for all we know. We could have called it any word we wanted to. But how are we going to make it act as the population size? Where do we need to sort of hook it up, connect it, so that it actually acts as encoding the population size? Where is the population? Where did we previously see the population size? What has been the population size? Okay. Yeah, it's in Maine. Okay, so good. It's in Maine. Where is it specified? Yeah, so let's click on population. Where is that specified? Yeah, 100. So what do we need to put instead of 100? Population size. And as Dylan said, you could start typing it, control space, fill it out for you. And this is being slow, but it'll say population size. It'll give you, and by clicking on that, boom, you're going to be setting it. Okay. So let me try that again. POP, control space, and it's going to present me a. Oh, hey, what just happened? Control space, and I'll just double click on that. Boom, population size. Dylan.
Either option, command, or curly. So it's option. It's option. Okay. Yeah, so option space.
Option space. It is. Okay. Thank you. Thank you very much for reading that. Much appreciated. Okay. Okay, ladies and gentlemen, that's good. But what is going to specify the value? We talk about parameters encoding and communicating values, communicating them from the point of creation, like where the population creates each person. It needs to communicate the value of the income to that person. So what is it that creates Maine? How did we run a model to create Maine? Where did we go? We went to an experiment, this thing over here. That's responsible for bringing Maine into existence, letting it run, and bringing it out of existence. And soon enough, we'll be seeing particular experiments that actually run Maine many times, such as a parameter variation experiment or calibration. So we go to the experiment to specify the value of this parameter for population size. Okay? So we're going to have a default population size, say 100, for this standard experiment, and then we're going to create. Well, let's run that. Let's run that. Should we see it? Should we try that? Run early, run often. Let's put it into practice. Okay, so, oh, look at that. It's giving me grief. Oh, I forgot something. My jet lag is showing. Yeah, we need to actually make, it's an unhappy camper. Well, let's learn how to deal with it being unhappy. So you'll notice that this is the error message. It says type mismatch, cannot convert to double to int. And it brings me to this thing, population size. And it's because population size, just as Joe spotted it, eagle-eyed, you have to make population size not a double, but an integer. Why? Because it's counting things. 0, 1, 2, 3. It's not 34.235 people, like it would be incidentally in a system dynamics model. But instead we're counting the number of discrete individuals in the population. Okay? Okay, people, did you get that, folks? Okay, so what we needed to do, we needed to go to population size, and eagle-eyed Joe spotted the type of this population size needs to be int, not double. Okay? Okay. Are people comfortable with that? Okay, can we run the model now? Run or not? Okay. Okay. So we see this. Okay, now suppose we wanted a big population. What do we need to do? We want to have a scenario which involves a big population. What do we need to do? Ladies and gentlemen? Okay, yes, but let's do it in a principled way. we could actually go and change the population size for this one scenario. But ladies and gentlemen, scenarios are put there for a reason. Scenarios involve executing the model under different assumptions. Mark my words. Scenarios involve executing the model under different assumptions. So we're going to create a different scenario for a big population. How would we do that? Riddle me that. How would I create a new scenario? What do you think I would do? Sorry? Would I go to person? Would I go click on the person picture? Where would I go to add a new scenario? Give me, I know you've never done it before, but I'm asking you to build intuition. Where would I go to add a new scenario? Where do you think I'd look? Yeah, new experiment. No, because it's a sort of high-level thing over here. It's not under person. It's not under main. It's under the whole model. So I do new, and I do experiment. Boom. And I'm going to say big population. Okay? You could call it something more descriptive if you want. And I'm going to make its population size 1,000. Okay. Are people comfortable with that? Are people comfortable with that? Okay. So let's not lose track of this. These things from the palette, they can go within an agent, a particular person, or they can go within main. If you have a parameter, yeah, it's typically used to, or it's very commonly used to describe the assumptions about a particular person, but it could just as well be used to characterize the assumptions to use for the model as a whole by putting it as a parameter in main. Does that make sense? So, ladies and gentlemen, we created a new experiment, and the parameter for main, the thing that specifies the value of the parameter is the experiment. It says, assume a population size of 1,000. For a person, the thing that specifies that value is the population, or the point where that person is created in code as well. Okay, so can we run this big one? Run or not? Run. Okay. Okay. Boom. Area of big population. Big or not? Big. Okay? Yeah. Great. Okay, but we'll finesse one final thing, and then we'll go another direction that we haven't gone before by adding dynamics. So, ladies and gentlemen, this one final thing. By the way, you notice you can explore this model. You can go find things over here, in the so-called canvas, and that's all well and good. But another way you can find those things is by going over here in the project and finding things within the project. Okay? And so you could go explore population size here. And you'll notice there's a default value here for this. What this just means is when there's that parameters area, if you don't specify value, what value should it use? What expression should it use? So let's use the default value of 100. That'll just be our default value. If no one specifies it for new experiment, it'll use 100. Okay? So it's kind of a convenient thing. It'll fill that in if no one else fills it in. It's not the initial value. It's just the default value. If no one fills it in for an experiment, it will use 100. So, do we need it? No. But it's a convenience. It means when we create a new experiment, it's automatically filled in as a default. Okay? People comfortable with this? Okay, great. Do you want to do a really big population? Like 10,000? What do you think? Okay. New. Well, you tell me what to do. What do I do? Do I go and frob the picture of a person? What do I do? Yeah, new experiment. That's good. I frob the whole model. Okay, new experiment, and I'm going to say very big population. Okay. Now, obviously, in a real model, I'd probably be quite specific. I'd say population, of 1,000 or probably 10,000 or what have you. And And how am I going to operationalize it? By the way, where did this 100 come from? That's the default value. Yeah. So I'm going to make it 10,000 here. Is that okay? Okay or not? Okay. Okay. Oh, is that right? What's the maximum? 5,000? Okay. That's a good thing with a capital G and T. Okay. There we go. Okay, folks, you notice that we can also, by clicking here, we can go drill down. You notice also it shows you how big the population is up here. So these are a lot of people crowded into a limited area. Okay, that exhibits high population density. Western Sydney at 8. Okay, so ladies and gentlemen, are you feeling okay with that idea of a parameter in main? Okay, so let us now lend this model